So the first thing I did here is dismantle the mock-up and then went through with each piece and made sure it fit right in there like it was supposed to. Checked I guess basically confirming all of the measurements. So now we're ready, everything fits, so we're ready to start soldering. I'm gonna start with the Nano here because that looks like it's going to be the biggest deal. There's a whole lot of pins to solder on that. So make sure it's oriented correctly and it fits in nice and snug. Actually holding in on its own, which is going to make it a whole lot easier to solder because everything's really snug there. So I think I'll go over the steps for soldering on just a pin or two, but then all the rest of these will be the same. I guess the resistors will be slightly different. So I'll just do a couple pins here and then go over the steps for soldering the resistors and yeah, get all these pins soldered in place. There's a whole lot of them. Okay, so now the setup for soldering. I have some rosin core solder here that tends to work really good. Silver rosin core solder that works really well on the circuit boards, so we don't need any additional flux or anything. A soldering iron. A stand's important because you need to be able to hold that securely. All right, it's very hot. You want to be careful with it, obviously. And I've been trying different things. I guess this started about 6 months ago. I actually take previously I've always worked with chisel bits, but about 6 months ago, trying different things, I'll take the pointed bits, the ones that have a very sharp point, and I'll trim off the end. They tend to wear down a little bit quicker, but I found it works really, really well for circuit boards, for PCBs. So I've been using that for about 6 months and try different things. I might change it before long. And then here is a sponge to kind of clean the tip off between runs, and the sponge is soaking wet. Like, you want the sponge soaking wet and don't wring it, don't squeeze it out. Just leave it soaking wet. So that's the solder setup. The soldering iron, some rosin core solder, a stand, and a place to, a sponge to clean the tip, or a Brillo pad works really well, but I don't have a Brillo pad right now. So I'm gonna go with the sponge, and then, yeah, I guess for about 6 months now, I've been taking the very pointed tips and just clipping the end off of them to have a nice flat surface to start on a big project like this. And it'll probably wear most of the way down by the time I get through the board doing that. But we'll see what it looks like. Along with the soldering iron, a very important piece is something to hold your pieces secure while you solder them. This is a tool called Helping Hands. I have an extra little soldering thing, stand holder. I should have thought about a word before starting the video there, but something to hold the soldering iron. A magnifying glass with an extra little light to see well. And it originally had 2 here, and then I took apart another cheap Helping Hands thing to add a third one to hold, because one of the main things with solder is you never want to place anything with solder. You never use the solder to try and push stuff into place. It needs to be held into place and staying there, and then the solder sits on top of it once it's already in place, just to permanently lock it. So something to hold it. This little Helping Hands tool here. So we'll mount the board here and get started soldering. Okay, so we're ready to start soldering here. And our process, bumped my gooseneck. I've found that a temperature of about 653 on the soldering iron seems to work really well with PCBs. So we'll bring the soldering iron in and heat up the metal that we're going to attach the solder to. And then we use the metal to melt the solder, then pull the solder away, and then pull the iron away. And to make sure there's a really good connection, it's a good idea to tin the tip. So we're going to take just a little bit of solder and put it right on that tip so that there's like a liquid surface on the edge and get really good contact between the iron and the metal pin that we want to heat up. Give that a second to heat up. And now bring the solder in very carefully and use that pin we heated up to melt the solder, and it should flow right down into that groove. And trying to do this on the video, got a little bit of a burnt spot there. Shouldn't be a big deal. I don't think it burnt through. Might have melted the plastic a little on the other side. I'm used to doing this quicker without the video, but one more time on that. Bring the iron in, heat up the pin. As it gets hot, then bring the solder in, use that piece of metal to melt the solder, then pull the solder away, then pull the iron away, and then come down and examine closely to make sure the solder flowed down that hot pin and filled in the little hole to lock everything in place. So now that I've gone over those a couple times, I'm going to get the camera out of my way and do a few more solders, because there are 78 pins to solder, 78 things to solder. Almost all of them are header pins like this. The resistors are a little bit different, so why don't we go ahead and do a resistor real quick, because now that there's 2 pins soldered in, I feel confident that this will stay in place now, so I can move it away from my helping hands a little bit and get more degrees of freedom. Kind of restricted on that first solder or two, holding where everything has to be held in place tightly. But now that I've got a couple on the Arduino, that one's going to stay in place. So let's do a resistor and go over that process, which is very similar. The only difference really is how I lock those in place. So let me put a resistor in there and I'll be right back for the video. So real quick, to see the only other type of solder besides the header pins here, I went and grabbed one of the resistors, stuck it through the holes, and on the other side, with resistors and capacitors and things that have long leads, I like to bring them through and bend them so that they hold themselves in place long enough to get the first couple solders in there. So I'm going to kind of stick that someplace where it's not going to move. I guess I could lock it in place. Okay, it's not going to move there. Try to get that, well, I don't think I'm going to be able to get the reflection of the light off there. And then the process is the same. Bring the soldering iron in and heat up that piece of metal you want the solder to stick to. Then bring the solder in from the other side, allow it to melt, fill in the little hole, remove the solder, and then the iron. Maybe just a touch more there. There's nothing around it. There we go. And then to clean it, I have the soaking wet sponge, so just wipe that off. And once that solder is in place, we can grab some little snips, give that a second to cool down, and then trim off the excess. There we go, that'll work. So that's 3 down, 75 to go. And it's that same process over and over again. So just slowly, carefully, taking time. With 75 solders, I will definitely be taking several breaks along the way. And probably spread that out over a few hours so that it's definitely not a part to rush. So I'll get started finishing up these solders, and then we'll get back to testing, well, get started testing the prototype rather than the mock-up. Okay, so since this is the first design, I want to check lots of things along the way. Kind of the same reason the first step was to plug in all the pieces and make sure the measurements were right. So I soldered up the nano and the resistors. That way the ground rail should be unbroken, so I needed those in there as well. And now should be able to check the 5 volts and ground on all of the 5 volt and ground connections. So first thing, Oh, and also where I got the scorch mark here, holding it there a little bit too long for the camera. I want to check that. It is on the transmit pin, the UART transmit pin, which I never use those first two because that's the UART communication, which is the same one. Whoops. The same one the USB port uses. So can't use those two at the same time. So I almost never use those unless there's like a Bluetooth antenna that they're going to or something. And even then, I'll usually try to do a serial reassignment and use one of the other parts for UART communication. So I pretty much never use those pins, but I still want to check it. So I'm going to stick this in one end of the meter in one of the grounds, and on the board, on the breadboard, I was getting 4.6 volts. So if I come over here and check the 5-volt rail, looks like 4.58, 4.59, something like that. So I'm going to start with that one that I got a little bit of scorch on, because it's UART transmit line, so I should be getting 4.6. Yep, getting the full signal there, so that scorch didn't hurt anything, just kind of blackened up the plastic a little. So now I want to go through and check all of the 5-volt lines. So all of the 5-volt lines, 4.58 to the flip switch, 4.58 to the twister, looks like 4.58 on the UV joystick, 4.58 on the XY joystick. It's there for, got the voltage on both of the slider connections. The power for switch 1, switch 2, switch 3, and switch 4. So looks like those are good, but I want to check the ground as well. So I'm going to all the grounds. So, well, I know that ground's good, so I'm going to plug this up, stick the other end into one of the 5-volt ones, and now come through and check all the grounds. On the flip switch, it's just a pull down is all we have for the ground. Oh, it looks like it's there. Can't really get a good connection on that one. Do I have a good connection there? So it looks good there. And there. And there. There. Really already checked this one. Check the rest of these. So it looks like all of the grounds are good as well. Oh, signal. This one. Yep, so it looks like all of the 5-volt and power supplies and grounds to all the components are good. And since this is the first one, just wanted to confirm the design. So now I will get back to soldering. And still got quite a few pieces to solder, but you can see it's well underway. And there's 30 on the Uno, so out of 78 solders, the 30 on the Uno are almost halfway already. So I'll get back to soldering, and just wanted to do a quick voltage check to kind of confirm the design along the way. And these confirmations only need done on the first one, because any other PCBs we order will come from the same design. Just want to make sure, just check and see if we need to order another one before we get too far along to undo all the solders. So it took a while. I went very slowly and carefully, again continuing the test. So just like we saw previously, since this is the first one in the design, every time I soldered in a new component, I plugged it up and retested it. But everything's here, seems to be working. So we're ready for put the plastic caps back on and get back to testing. And so here it is, all finished up, all soldered up, and every piece was tested along the way. Plugged it every time I soldered in another piece, I plugged in along the way, and I did decide to go with that on top because I can easily reach that with my index finger. Got the knob, and so towards is 0 and away is 100. This has 100 over here and 0 over here. So I was thinking I'll mostly use that with the right thumb. So it made sense to have 0 pulled close and 100 pushed away. The buttons are easily accessible, as are both joysticks, or use them one at a time with the buttons. And there's a lot of different combinations of what this can be used for. So, time to get back to testing. Have those mouse controls set up, so I'll give that a run and check it with that. And start planning on video games. Obviously going to need a simple 2D game, maybe a 3D game. Then I was thinking maybe a racing game where I can try these. Do the acceleration with the slider and the steering with the knob and see how that goes. And basically just lots of testing now. Everything feels solid, but I think I will wait until there's a plastic case before I try the throw it at the wall testing. But it seems to work, and every piece worked on its own, so now it's time to get back to the more thorough testing, and it seems like this is going to fit the needs that I had on that project pretty well. And the design all worked out, so don't have to check it all the way along every step along the way again, because everything in the design checked out. So if we need more, can just order them from the factory and they'll print out that same design.